Good afternoon, and thanks for having me here. My name is Dan Schultz, and I am a program manager for State Water Board Division of Water Rights, and I oversee the cannabis section. And today I'm going to just kind of provide a general overview of the Water Board's authorities and some efforts that we are undertaking and have taken related to protection of public trust resources and in-stream flows. So in general, I'll go ahead and cover some general background of the State Water Board authorities, some definitions, and then we'll go into some of the efforts that we're working on. So in general, as a little background, the State Water Board's mission is to preserve, enhance, and restore the quality of California's water resources and drinking water for the protection of the environment, public health, and all beneficial uses, and to ensure proper water resource allocation and efficient use for the benefit of present and future generations. We have dual authorities. We have both water allocation and also water quality protection authorities to provide a comprehensive protection of California's waters. And basically, these together, we look at beneficial uses, water quality objectives, and anti-degradation, as well as the protection of public trust resources. And we also serve a balancing role between water allocated to the environment and for human consumption and use. So some quick, just general definitions. There's two different definitions, essentially, of beneficial uses of water. We'll go ahead and start with the water rights, and the way I like to think about this is that when you take water out of a stream, these are the beneficial uses you're putting that water towards. These include things like domestic uses, irrigation, as well as municipal, fish and wildlife preservation, and along with frost protection and a number of others. And these are established through the California Code of Regulations, the beneficial uses you can use water for. There's also beneficial uses of water associated with more of the water quality control planning or this policy for water quality control development. And these look at more at what are we protecting the water that's in the stream to be used for. So they are established typically through a basin plan setting activities. And these are looking at things usually more towards the in-stream flow uses, but also can include some water extraction uses as well, as you can see in this list. But some more general examples are things like water contact for recreation to make sure that the water's clean enough for people to recreate in and swim in, cold and warm water fish habitat, spawning habitat, ag supply, sport fishing, and those types of uses. So we also have public trust authorities, and the State Water Board is responsible for protecting the public trust, which includes commerce, navigation, recreation, and habitat for fish and wildlife. And in general, the public trust is the uses of water or the uses of our resources for the benefit of the people of the state, first more for an individual or other type of use. And so whenever we do go through our planning and allocating of water resources, we always need to take these into consideration, and we also have authority to take public trust actions as well. So today, most of our focus is going to be on the discussing some of the ecological flow criteria development and establishing what types of flows are needed in the streams for the maximum benefit of aquatic resources. And so I wanted to touch a little bit on the State Water Board's role within that. So there's two different components. There's the flow criteria, which flow criteria does not have a regulatory effect. And it identifies basically the range of flows needed, in-stream flows needed for aquatic dependent species availability. What the State Water Board's role is that we balance the in-stream flow uses with the other beneficial uses, which we discuss mainly on the water rights side, which are what we're using the water for, to develop flow objectives. Or environmental flow objectives. The flow objectives do have a regulatory effect. The purpose is to balance the public trust resources and other beneficial uses. And it's the balanced amount of water that is established to ecologically sustainably meet all needs in the watershed, which include human consumption and use. And those are typically established either through a policy or a regulation or can also be done through basin plan activities. So now I just wanted to quickly just kind of provide some context for the rest of the presentations in the panel, go over a couple items actions that we've taken in the past that were related to establishing in-stream flows. In 2011, the board adopted the Russian River Frost Protection Regulations. These basically established minimum thresholds to be developed in the Russian River watershed to ensure that frost protection was not stranding or causing mortality of salmonids. Basically, the way that works is when it's a cold day, all the pumps kick on at once, and people that have diversions straight in the stream and some that are closely connected to the stream with wells, we're dewatering the stream and causing fish mortality and fish kills. The second one is the policy for maintaining in-stream flows in Northern California coastal streams. This one was looked at as more of establishing conditions that people need to meet to ensure that water is available for diversion in the in-stream flow policy area. So it's not going back in time, it's more looking for future permits and how we manage allocating more water at this time. In 2017, there was the cannabis cultivation policy, which is principle and guidelines for cannabis cultivation, and this was based off the more recent legislation and the proposition adopted by the state to develop requirements to ensure that the diversion of water and discharge of waste related to cannabis cultivation do not negatively impact in-stream flows. So in this situation, there are very specific diversion rules and in-stream flow requirements associated with cannabis cultivation for the extraction of surface water, and also potentially requirements that would extend the groundwater in certain circumstances. And then the last one on here is the Bay Delta Plan update for the Lower San Joaquin River and Southern Delta. This one went into effect in February of this year, and this established some water quality objectives for the Lower San Joaquin and Southern Delta. And we also, during the drought in 2014 and 2015, we also took some emergency drought actions, and that included an emergency regulation for the curtailment of diversions in Mule Deer and Antelope Creek, tributaries to the Sacramento River. So basically this established minimum flows that needed to be in stream, and also some post flows during the spring into early summer to support migration of spring run up into their holding habitat and eventually spawning habitat, and also extended to sometimes outside of the spring to looking at the in-stream flows needed for steelhead passage as well. In 2015 and 2016, we adopted a regulation for water conservation and additional water use information in 4 priority tributaries in the Russian River. That was Green Valley, Dutch Bill Creek, Mill Creek, and Mark West Creek. And this one was more targeted at the use. So among other things, we had the statewide conservation regulations for that regulated how people should use their water, like don't water your sidewalks, no washing of cars, all of those. But they only extended really to surface water and to municipal water supplies. In the Russian River, a lot of the issues actually come from groundwater extractions, and so we extended those rules to groundwater extractions as well. And we also developed a requirement that prohibited the irrigation of ornamental turf or grass lawns. And a second part of that was there's a lack of information in these areas because of all the groundwater diversions and not as much information supporting how much they're taking where they are. And so we included informational order authority to collect that information from landowners so that we could have a better idea if we needed to take actions moving forward in those watersheds. So now kind of moving forward to some things we're working on right now. I wanted to touch on 2 directives we got through the California Water Action Plan. The California Water Action Plan in general was developed to meet 3 broad objectives: more reliable water supplies, the restoration of important species and habitat, and a more resilient, sustainably managed water resource system. There was carved out in there was Action 4, which was to protect and restore important ecosystems. And within that, there was a sub-action, which was to enhance flow in streams statewide. And it's targeting 5 stream systems that we're working on right now in collaboration with California Department of Fish and Wildlife. And they are, if I can get them all right, Shasta River, the Mark West Creek tributary to the Russian, Mill Creek tributary to the Sacramento, Ventura River, and the South Fork Eel River. And then more recently, in April 2019, Governor Newsom signed Executive Order N-10-19, which directs the Natural Resource Agency, Environmental Protection Agency, Food and Agriculture, in consultation with Department of Finance to prepare a water resilience portfolio that meets the needs of California's communities, economy, and environment through the 21st century. So this is a new activity that we're looking at this point moving forward. And I'm sure you'll hear more about that over the coming years. So going back to some of the stuff that feeds off of what we were just discussing, efforts under development, we're currently working on the Sacramento Delta update to the Bay Delta Plan. As I mentioned, the California Water Action Plan efforts are underway in all 5 tributaries. And then we're also working on cannabis cultivation policy updates. The way that the legislation was passed was that we were developed interim and long-term requirements. We've developed the interim requirements, and we're moving towards long-term, which will be focused primarily on regional in-stream flow requirements for cannabis cultivation. And then we're also working with a number of the panelists that you'll see following me on the development of the California Environmental Flows Framework and Regional Flow Criteria Methodology. And we're doing that through, we're the primary funder of this effort through a contract with UC Davis. So I also quickly wanted to mention one of our ongoing working groups, where a lot of this is, we have a lot of conversations in this group, and it's a new group. It's California Environmental Flows Work Group under the Water Quality Monitoring Council. The mission is to advance the science of ecological flow assessment and its application for supporting management decisions aimed at balancing natural resource needs with consumptive water uses to establish environmental flows. So this group is really looking at developing the science to take the next step forward for the regulatory step of developing the environmental flow objectives. I just wanted to put up here in case people are interested. It meets quarterly in November, February, May, and August on the second Tuesday of each month from 9 to 3:30. And I'm one of the co-chairs along with Robert Holmes with the California Department of Fish and Wildlife, and that's our contact info if you want to follow up with any information. And you can also sign up for the LIRIS list. I don't know how many of you have signed up for them, but they're pretty simple. In the top right corner of all our websites, you'll see a subscribe button. Click on that, go to the Water Board's box or link that will take you to the Water Board's LIRIS list. If you scroll down, you want to enter your information at the top, then you'll scroll down to the General Interest tab, and you'll find under the under Monitoring Council work groups, the California Environmental Flows work group, and then you have to go all the way back up to the top to subscribe. And that's all I have for now. I'm sure we'll hold questions for after, I assume. Thank you.
Thanks. Yeah, I think we'll hold the questions since we have the half hour for the panel at the end. And as Greg alluded to, and Dan in his final slide, this is definitely a great collaboration between the Water Board and Department of Fish and Wildlife, as well as all the technical partners. So with that, I'd like to introduce Amber Villalobos, and there she is, representing the Department of Fish and Wildlife, who's going to give you the perspective from the other co-lead state agency on this effort.
So does everybody in here really love policy? You know, 10 years ago, I didn't think I would ever love policy, but I actually really enjoy the stuff. So as Eric introduced me, my name is Amber Villalobos. I'm one of the senior environmental scientists at the California Department of Fish and Wildlife. Work for the Instream flow program, where we evaluate streams and we will develop in-stream flow criteria for fish and wildlife needs. But also in the audience, I kind of want to point out that I have a couple of my colleagues, my team in the back there, if I can get them to stand up, because all the work that I do, these guys are like the backbone of things that I do in the office, so I just kind of wanted to thank them. Oh, wrong way. Whew. So as far as an overview of the presentation, I'm going to cover very briefly some of the state policies and mandates, the Department in-stream flow program, in-stream flow studies, as well as some of the new tools and benefits of those tools that have been developed by members of the panel that we're really grateful for, and yeah, and just some of the benefits that we see using those new tools. So most of the policies that actually Dan already mentioned, they also apply to the Department of Fish and Wildlife. We do to also have a public trust responsibility that says that all the public trust resources, fish and wildlife being one of them, are held in trust for the state of California, and that they need to be preserved and protected for current and future generations. Another driver of why we create in-stream flow policy, or I shouldn't say policy, in-stream flow criteria, is the Public Resources Code 10,000, also known as 10,000 through 10,005. That's a code where it was recognized that fish and wildlife are important for the state's economy, and so under that code, the department director was basically told that the department needs to develop in-stream flow criteria for streams that are important for the resources, and then present them to the State Water Board for their consideration in the appropriate water rights process. Another code is Fish and Game Code, is 1602, which is also referred to as the Lake and Stream Bed Alteration Agreements. And for those, if there's going to be a project which is going to divert or obstruct stream flow, a project proponent will notify the department, provide a summary of what they plan to do, and then the department will go in, evaluate it, and provide measures to protect the fish and wildlife resources. Dan mentioned the California Water Action Plan, which we identified 5 streams that were critical habitat for fish and wildlife resources. So I won't get into much of that since Dan already covered it. And then most recently is the Water Resilience Portfolio, which the governor directed the agencies to get more creative with water management and develop more information on how we can protect our communities as well as our resources. And Governor Newsom recognized that we have some species that are on the verge of going extinct, and it's important that we need to do more to protect these species, because we don't want them to end up similar to like the photos up here that I have. On the far right is the California grizzly bear, which is now extinct, and he's eating a salmonid. In the middle is the thick-tailed chub, which Jacob Katz provided a good introduction and background. So the thick-tailed chub used to inhabit the areas of the Central Valley, but with all the anthropogenic changes, that fish has now gone extinct. And then just for cuteness factor, there's some western pond turtles on, on the other side, which are a species of concern. Okay. So as far as the department goes with in-stream flow criteria creation, historically and currently we had 2 different kinds of studies. Well, I'd say previously we had one type of study which was really labor intensive. It took a lot of resources to develop. We needed a lot of expertise to develop them. We spent a lot of boots on the ground times to develop this information. And it was scientifically defensible. It was highly needed information, but it was just took a really long time to get this information together. Currently, we're developing a new rapid approach using the tools that the group has developed to create a faster way to go through and create ecological flow regimes. And I have a couple slides that go over information, but I'm not going into too much depth because the other presenters are going to present on it. But these are kind of one of the key 2 areas, key tools that we're using for the rapid approach, that we could not actually create this rapid approach without these tools. So we're very grateful to have them. So the first one is the Natural Flows Database. TNC, along with USGS, collaborated together and evaluated streams throughout California and created this system to provide monthly stream flows for many segments throughout the state. So before, when you're going through and trying to create unimpaired flow or natural flows, it was time intensive, it was practitioner dependent on the information you would get, and a lot of times you couldn't really get people to agree. So this is one tool that's providing consistent base information for us to know what kind of water flow would we expect in that stream given an average year, a dry year, a wet year. What might we anticipate without any diversions or human changes to the landscape. Another tool is the functional flows documentation and calculator. that provides some key information about timing, magnitude, and duration of flows that we'd want to occur in a natural system. In the past, components of this were implemented in odd ways, but with this new information, it's presented in a consistent manner, and it's actually a tool that can be applied throughout the state. So what this means for the rapid approach is we have consistent base information, we have some consistent tools. This means that the department can develop this much needed information in a much faster way. We need fewer resources. We could create criteria with or without site access potentially, which is a great time saver and cost saver for the department and for the state. We can create criteria on a broad scale or a fine scale. The picture up on the screen, it is shape of a watershed, and you can see that on this particular example, we've created potential criteria for 42 different portions of the stream, and it could have been more extensive, it could have been less extensive, but it was just an example that we wanted to provide. And this information can be developed instead of on years, it can be developed in weeks. So again, we're very happy to be part of this collaborative group, and we're very thankful for the members of the panel moving forward, creating this information. And if you have any questions about the department's in-stream flow studies, either our past ones or our new approach under development, my contact information is up there, as well as our in-stream flow program website. So you can reach out to me, you can take a look on the website, and we have a designated person to contact. But we look forward to any comments or answering any questions that you might have. All right, thanks.
Super. Okay, great. And so that, I think hopefully now you have with the Dan and Amber's talk a good background on kind of some of the policy drivers. And so our next three talks are going to focus on some of the technical tools that have been alluded to by the first two speakers and get into more detail, and some of the tools and data that are driving the formation of the tools that Amber alluded to. So I'd like to introduce Sarah Yarnell, who will be our next speaker from UC Davis. She's going to give you an overview of the California Environmental Flows Framework.
Thanks. Happy to be here. So you've heard a little bit about the collaboration that's been going on, the Technical Flows Working Group under the Water Quality Monitoring Council that Dan talked about. And in general, this group is working towards developing the California Environmental Flows Framework. And I'm going to give a brief overview about that, and then the next couple speakers are going to talk a little bit more in detail about some of the tools you've heard to that Amber has alluded to and Dan has alluded to. Hold on a second here. Okay. So just to give a super broad overview, we know how impaired the water is across the state of California. There's been a lot of, recent studies that have sort of quantified this, but in general, most everybody who's here and anybody who works in water recognizes the fact that the impacts on our streams and rivers throughout the state are pretty substantial. In general, the types of patterns that we see are depleted flows in wintertime. Peak flows do not necessarily pass down the rivers and streams anymore. They're often kept back in dams, held back for water supply or flood control. So we see a depletion of winter flows. And then as flow deliveries happen in the summer, we see an augmentation of summer flows. And so what this does then is essentially decrease the amount of variability that we have in a lot of our rivers throughout the state, in different portions of the state and throughout the year. And this decrease in variability goes directly against what a lot of the natural flow regimes that our native species have evolved to. So a lot of what Jacob alluded to in the beginning was this idea of if we're trying to put functionality back into our river systems and create multiple benefits, how best can we go about doing that? And one of the premises behind the approach that we're taking is this idea of restoring seasonality to a lot of our flow regimes in the best that we can. Additionally, as you've heard from both Amber and Dan, from a policy perspective, California is a huge diverse state. We have incredibly different watershed systems from the very north of the state down to dry ephemeral streams in the southern part of the state. And we have a huge diversity of water uses throughout the state, both in terms of human consumptive use, in terms of economy, agriculture. And so the management needs vary quite a lot across the entire state. In addition, we have multiple agencies, not just the 2 state agencies that you heard from today. There are federal agencies with water responsibility, U.S. Forest Service, BLM. They participate in the relicensing of hydropower dams. We have local water groups, local water districts, and so there's a complexity in terms of uses and people who are using water throughout the state, and there's really a lack of coordination among a lot of these different agencies. There's not necessarily good sharing of data a lot of the times between these different agencies, and multiple groups can be working on individual watersheds, and this really creates inefficiencies and a lot of redundancy in the way that we approach how we deal with trying to determine and balance water uses within watersheds. So there was really a need within the state to get some of these groups to start talking to each other and come up with a more coordinated framework for how we should go about approaching water management within the state in a way to try to attempt to balance these multiple objectives, bring the science together to understand ecological flow criteria, and try to make some progress moving forward with that. So this technical working group that Dan has alluded to has sort of essentially started the development of the California Environmental Flows Framework. We call this CEFF for short, because you need an acronym for everything, of course. And essentially what CEFF is the idea that within that framework, we're going to focus first on the science and the best available science. In particular, we're going to focus on the ecology of the systems and the natural hydrology or altered hydrology of the systems to better understand what the ecological needs are within that system and set ecological flow criteria based on the initial needs of the system first. And this is where the science really comes into play. And so most of the folks that you'll be hearing from the next couple talks, like myself included, are the science experts that are trying to help then inform the policy. Once we come up with these ecological flow criteria, then we sort of pass off to our policy and agency partners, where then there becomes some guidance or discussion about how best to go about balancing these different multiple objectives. Things like water availability, water demand, how do we go about really figuring out what flows are needed and what flows can be retained within a system for the ecological functioning in addition to providing water supply. And the reason these decisions are outside of the box is that these are really social and policy decisions that we as a community need to develop. Science can help inform those decisions, but at the end of the day, it's a regulatory, policy-based decision on how we're going to manage our streams. And so we explicitly recognize that in the framework by providing a science-based, informed set of decision-making tools and data at the front end, and some guidance for considerations that stakeholder groups, agencies, nonprofits, local water users together can consider and talk about as they make their final ecological flow recommendations. Okay, so here's a little bit more detailed view of what CEFF is. In essence, it's a 2-tiered approach with the science. And again, the science is sort of the box on your left, and then the policy boxes are on the right. So we have a 2-tiered approach. The first tier, you're going to hear a little bit more about, but essentially it's a statewide functional flows-based approach to establishing flow criteria for every stream in the state. It's a single methodology that's based on reference flow conditions, building off of the natural flows database and our understanding of what natural ecological systems in California would need. This methodology and set of tools provides you with a starting point for what your ecological flow criteria could be. In many cases, this may be adequate for a particular watershed or a particular water user group, or it might need further refinement. For example, if it's a heavily managed system and there's not enough water to provide those full ecological flow criteria, you then might move down into a more detailed local or regional scale, a tier 2 framework, where you bring more data to bear. You might do more modeling to really balance those needs or better understand the flow limitations within your watershed to help you refine those flow criteria to come up with a final set of ecological flow criteria that then can go on to the social decision of how to manage and allocate for those flows, which is outside the box. And as I've said, all of this is inherently based on the functional flows approach. So Jacob alluded to this beautifully this morning with the early afternoon with the first talk. And the idea of a functional flow is we want to focus on those key components of the hydrograph that give us the most ecological bang for our buck. So California is a highly seasonal location. We get our rain in the winter and we don't get rain in the summer. We have a bigger drought every single summer than the East Coast has ever seen. We don't get rain for 3 to 6 months. Our native species are totally evolved to this. And so when we change the hydrologic system to lose this seasonal variability, you're essentially taking away the advantage from our native species and providing an advantage, like making it more advantageous for the non-native species to come and invade the system. So the first thing we want to do is to try to pull back from that and acknowledge the fact that we want to reintroduce seasonality into these flow regimes. And in particular, we might focus on 4 key components here in California that are broadly applicable across the whole state. The first one is those peak winter floods. Exactly like what Jacob talked about, you need high flows to go through and scour sediment, redistribute sediment, reconnect to the floodplain, flood out into the overview areas, give that floodplain habitat out there, and really do the work, the ecological work of the ecosystem. When at all possible, we want to retain at least 1 or 2 of those flows within the system every year. The second key component is the spring snowmelt recession. So all streams, even down in Southern California where Eric lives, and they're very flashy, there is a transition from the wet season to the dry season. And this transition does not happen overnight. You don't just magically shut off a valve and say, it's not raining anymore, all the water is gone from the streams. That's not what happens in nature. There's a gradual draining that happens through all the watersheds that happens during springtime. And this is a very, very predictable time of year that all of our native species are cued into. If you take those cues away, the fish then may or may not have an out-migration flow. They may or may not have spawning timing or cues that are given to them. And so we really want to be able to keep this flow transition, gradual flow transition, happening within the system where possible. The summer base flows, of course, California streams do go to low flow at summer, and artificially keeping rivers high is creating habitat for non-native species. It is okay to let the rivers go to lower flow in summer. Some of my fishy friends don't like it when I say that, but that's what the system was evolved to. We should have decreased flows in the summer in California relative to higher flows in the winter. And then the last bit is the fall seasonal pulse. This is the cue to begin and re-wet that season again for the species. So salmon are cued to look for this fall pulse to migrate upstream. And again, if you remove this cue from the system, you're sort of limiting the ability of these native species to function in their life history stages as they've evolved. And so the tier 1 steps of CEFF then essentially allow for this type of functional flows approach to be put into place. So Belle's going to talk a little bit about the stream classification, but based on where you are in the state, collectively the larger group has put together a stream classification to talk about what type of stream you're in. Am I in a snowmelt dominated stream or a rainfall dominated stream or some type of mixed stream? Based on that, you can explore reference hydrology for your stream. We have a set of gauges across the state, roughly 223 reference gauges that can be used to look at natural reference flow conditions for different parts of the state. With this information, you can evaluate the local reference hydrology for your stream class and get a sense of what those natural patterns and timings and relative magnitudes might be for your system. You can then go through and evaluate some actual functional flow metrics. So the bottom line when you're developing ecological flow criteria is I might say to somebody, hey, you need to put down a flood flow. But what they're going to ask me is how much and when and how long. So we have to be able to put numbers, discrete quantifiable numbers on these flow recommendations or metrics, flow metrics. What is the magnitude? When should this flow be released? And how often or how long should this flow be released for? So there's a way to quantify and calculate those functional flow metrics on this reference hydrology that provides actual numeric bounds for the targets you should be shooting toward. You can also then look at your local stream gauge. This is predictive flow modeling that's being completed up right now as we're sort of talking. Hopefully later this summer, this data will be appended to the natural flows database that TNC has. And again, this will be predicted functional flow metrics for every stream reach in the state. What are the bounds of those actual numbers for those functional flows that you might want to start looking at for your flow criteria? And then finally, then you can assess your actual local hydrology with what those functional flow metrics or flow criteria are to determine where you might be doing well in your system or where you might need to consider alterations or changes to the watershed management in that system in order to achieve those criteria. We'll talk a little bit about this, I think, in one of the next talks, but there's the functional flows calculator is at eflows.ucdavis.edu. This is where you can go in, look at the reference hydrology across the state, and actually pull out those reference functional flow metrics to give you a sense of what your ecological flow criteria might be. And then you've seen this, Amber alluded to it as well, but this is the natural flows database from TNC at rivers.codefornature.org. And this again provides monthly predicted modeled flows for every stream reach in the state, and we will be augmenting this website with those additional functional flow metrics for every stream reach in the state, modeled functional flow metrics for every stream reach in the state later this summer. So then if at some point you feel that you've got these ecological flow criteria for your stream reach, they are somehow not potentially doable, not potentially specific enough for the species of interest you might be looking at, you may then choose to go into a tier 2 guidance framework and refine those ecological flow criteria for more specific needs within your system. And in this case now, we're not prescribing a method per se, but simply providing guidance on the types of considerations that stakeholders, agencies, and groups that come together with this should be considering. In particular, you might be looking at your specific species of interest and management objectives within a particular watershed that you might want to take into account. Like, I really do care about salmon, and it's really all about salmon, and so I want to manage for salmon, and you acknowledge that, and that might be a focus for where you might refine your criteria. You'll be characterizing, potentially, you would want to characterize more of your local data. Perhaps you have more detailed flow data than what is provided on the websites, and that gives you a more accurate picture for your location. You would want to bring that information to bear. You might be looking at a more detailed environmental flow method. Maybe you'd like to look really specifically more at those summer base flows and determine, okay, what's the absolute minimum flow I can get by with where I'm retaining connectivity in the system? And you might go out and do a little bit of field work to augment and collect additional data to refine that summer flow criteria, for example. And you may look at flow ecology relationships more traditionally like an Aloha approach or something like that, where again, you're trying to limit alterations to the system that might affect the ecology in general. And so all of these considerations then are inherent within the Tier 2 section of the framework and essentially provide a place for stakeholders to come together, talk about the same data in the same place, in the same manner, so that they can hopefully come to collective conclusions about how to manage their watershed. And here's just a little bit more detail about the steps and the data considerations you might go through for that Tier 2. The working group is going to continue to be meeting. As Dan mentioned, we meet quarterly, talk about this stuff. There's a lot of different case studies actually that are going on throughout the state, which is great to hear about where things are working, not working, considerations people might have. And so at least myself personally have been really appreciating the value of having a lot of different policy and stakeholders come and talk about this type of work. And the overall goal of this is to come up with essentially a framework and guidance documents and data and tools for everyone in the state to sort of be able to hopefully make progress towards a more managed and balanced system in terms of their local watersheds. This information for the larger framework is currently being housed at ceff.ucdavis.edu. You can go there. You can contact me directly or pretty much anybody else that's going to be talking today, since we're all working so closely together on this. And at that point, I'll stop and take any additional questions. That's quick. Oh, questions at the end, that's right.
Thanks, Sarah. Okay, so our last two speakers, next speaker is Julie Zimmerman from the Nature Conservancy. So you've heard a little bit about the natural flows database. So Julie's going to tell us more about that. And then we'll finish up with Blaise Lane telling us about all the cool tools you heard about. And then you'll have time to pepper all of the speakers with all your questions.
Thank you. So I've had a nice setup on the natural flows database. We've heard about it in a couple talks already. So back several years ago, the Nature Conservancy, Jeanette Howard and Kurt Klossmeyer and me had been talking with USGS, Darren Carlisle, Larry Brown, Jason May, and Ted Grantham at Berkeley about setting environmental flow recommendations and realizing that one thing we were really lacking is a hydrologic foundation for the state. In most places, we didn't know what natural flows would have been. And if you don't know what natural flows are, there's no way to know what expected patterns of alteration might be or what ecological flows might be. And we've done some other work that's related where we've looked at the stream gauge network and found that 86% of streams in California are poorly gauged. So you really can't rely on just gauge locations if you want to have a good sense of hydrology. So we embarked on a big modeling project to try to predict unimpaired or natural flows for all streams and rivers in the state, gauged and ungauged. And the first step to this was to identify reference gauges. So we ended up identifying 250 reference gauges statewide in a 3-step process, or step 1, 1, and 1, as it shows here. So the first one is we did an initial screen by looking at places where there was low hydrologic disturbance and low disturbance to land use and had at least 20 years of data. And that was published in 2010 and came up with 146 gauges. our second step in the analysis was to look at places that passed the first hydrologic and land use screen but had less than 20 years of record, and that yielded an additional 45 gauges. And then our third step was to look at gauges that may not be referenced for their whole period of record. So there might be places where you have gauge data for 10 years that was referenced and then a dam went in or something, and then you have a change after that. And so we ended up taking partial periods of record for gauges that were considered reference for part of the time and got another 59 gauges. And then once we had all of these reference gauges, we decided to use a machine learning approach to see if we could predict their flows using data that we could collect for all of these sites. So we ended up collecting climate data that included precipitation and temperature and runoff, and then a lot of GIS-derived variables from the Gauges 2 database from USGS, so that included things like topography and soils and geology, and put it all in a database. That was the first step. And then the second step was to try to predict monthly mean flows, minimum flows, and maximum flows for all those gauge locations. So we trained the model on the reference gauge sites and then also tested it and developed a model that we felt worked pretty well. And then we used that model to predict unimpaired flows at gauge locations as well as ungauged sites. And at those gauge locations, you have observed data and then the predicted natural flows, and you can do some comparisons. So to do this, we have a paper that I can share with you that goes into the detail, but we broke up the state into 3 regions: xeric, interior mountains, and coastal mountains. We calculated 3 monthly statistics: mean flows, maximum flows, and minimum flows for the period 1950 to 2015. We had 113 static physical watershed characteristics. These were all derived through GIS, and then 39 climate metrics. And it ended up with a whole lot of models. And we used a random forest approach to calculate the mean as well as the 10th and 90th percentile for each of these metrics for each month. So we have a 80% prediction interval around each of these values. So, good, you can see it better than I can. It's just like a white screen right here. So when you go to the natural flows database, this is what you'll see. You can go here online, you can read a little bit about the science, you can download data directly using the API, or you can use the map tool where you can do some visualizations and click on individual stream reaches. And this is what it looks like if you go to the map tool. So we predicted flows everywhere on the NHD Plus National Hydrography Dataset. There's 2 colors to the stream reaches. There's blue streams, which are places where we don't have gauge data, so those just give you predictions of natural flows. And then the purple stream reaches are places where we have predictions of natural flows, but we also have stream gauge data. So if you click on a blue one, you'll get something that looks like this, which shows it's a visualization that shows the mean monthly flows for dry years across all years. Well, actually, it's now for the average year, and then wet years. And that's for the entire period of record, 1950 to 2015. And then on one of the purple segments, it'll also give you a line that shows what the observed values are for that same time period. You can also, on the bar on the right there, you can select stream reaches, multiple ones, you can select months, you can select certain year values, and you can download all the data directly and do your own visualizations. Or we also have a couple Tableau sites where you can go in for gauge locations and look at this for different well, you can play with the sliders and look at different years to get into more detail. So this just shows one of those Tableau sites for the mean monthly flows, and this is the Sacramento River at Keswick gauge. So this is downstream of Shasta, if you don't know it. And it shows the time period from October 2010 through August 2015. So the first part of that, I don't know if I can show the pointer here. Yes, okay. So this first year right here was a wet year, and the blue line, the dark blue line shows observed flows. The dark gray shows the mean monthly flow for each of those months. This x-axis shows the month and the year, and then this is the flow. So that dark gray line is the predicted natural flow. These lighter gray lines are the 80% prediction interval around that. And then in blue is what's observed. So that first year was wet, and you can see the observed flows followed those natural patterns pretty well, even though they were higher than expected in the summer. But then when you flip to the drought from 2011 to 2015, we get a flipped hydrograph. So you have the high flows of the year occurring in July and the low flows of the year occurring in March, which is opposite from what that natural pattern would be. So these are the types of things you can start to notice when you pull out the individual data. And we looked at this and we thought, well, could we do an analysis where we looked at patterns of alteration statewide? And we published this last year. I'm going to show a few sets of these maps here. This first one shows alteration to mean monthly flows across the state. So here the orange dots are flows that are depleted, which are lower than you would expect under natural conditions. The blue dots are inflated flows, which are higher than you would expect, and then the gray are not altered. And then the size of the dot is the magnitude of the alteration. So what the general thing that we found is that 95% of streams statewide have some alteration, that it's altered at some time, some point in the year over that period of record. But most places don't have only depletion or only inflation. Most of them are inflated sometimes and depleted at other times. So these are the same maps here, but this top set are the 1-day maximum flow for the year, and then the bottom set is the 1-day minimum flow for the year. So what we did is we took the highest maximum across the years or the lowest minimum so that we could get the 1 day. And we found that maximum flows are most often depleted, whereas minimum flows are most often inflated statewide. So what that says is that we've done a really good job of moving water around just like the water infrastructure was supposed to do. We've taken it from the wet times of the year and moved it to the dry times of the year, and from the wet parts of the state and moved it to the dry parts of the state. So for our next steps for the natural flows database, where we want to improve somewhat on our visualizations and try to put some more detail in there, we have some of our staff at TNC in-house working on that right now. We also have been working with AT&T and then some of our own staff to incorporate some new code to update the database over time. So right now it ends at 2015, but we're writing code so that it can pull the climate data every time it's available per month and just update the database so that it won't end there, but it'll go on in perpetuity. And then the final thing that we're working on is the functional flow metric prediction. So we're using a modified version of this approach to model the functional flow metrics at that same resolution. So for the same stream reaches that you'll see on the web tool, and we're adding that to the database, and that will probably be sometime this fall, summer or fall. Okay, that's all. Thanks, Eric.
Okay, great. And so all of these tools and data will be available through the various websites that the various speakers have alluded to. So our final speaker before we get to the panel discussion is Belize Lane from Utah State, and she's going to share some of the other cool tools.
Well, I realized we don't have a slide on. Okay. This slide has tried to pop up several times, so I know you've all been desperately waiting to hear more about it. So we've been talking about flow and hydrology, and fundamentally this is a water conference after all, so I promise to stay on topic. But I want to come back to what Jacob was saying earlier a little bit and talk about the landscape. So here, if we take water and we pour more water into this channel, we're going to see it start to spill out onto the floodplain. You can already see that kind of happening now, or up onto these bars. If this channel were much more confined and steeper, if you had the same discharge running through it, different things would probably be happening, right? It'd be moving its way downstream, maybe mobilizing sediment more rapidly, not necessarily spreading out. So we just want to acknowledge that the geomorphic setting is also really relevant. And like CDFW and Amber was talking about, we have some really resource-intensive, really valuable tools for trying to understand the geomorphic setting of the landscape and how that's going to affect the hydraulic conditions, but we're trying to develop, in line with these flow methods, some more regionally applicable rapid methods for understanding what's going on with our rivers. So we've developed this geomorphic classification, or we are in the process at the statewide scale, and the idea here is just like with the functional flows calculator and the natural flows database, where you can go into any stream reach in the state and say, what does my natural flow regime look like? And understand the months, what we think the natural monthly flow pattern is, or the timing of the spring snowmelt recession. Similarly, we are developing a classification to be able to understand the physical, or to our best ability, the physical habitat setting that the water is moving through at any location throughout the state. So this classification essentially classifies physical habitat. So we're talking about the sediment composition, the width, the depth, how that varies longitudinally downstream, and how it varies laterally up into the banks. And we'll talk a little bit more about that in a standardized, rapid, scientifically defensible approach that accounts for the inherent uncertainty in trying to get this at the reach scale. So the hope is that this will enable access to geomorphic information for thousands of miles of streams across the state. Just out of curiosity, how many of you are familiar with SWAMP's PHAB data set? Yeah, so the idea is to sort of build on that and expand on the geomorphic data that we're collecting to make sure that it's ecologically and geomorphically relevant at the state scale, and then distribute that information across the stream network. So why is this important? Well, we want to be able to refine our ecological outcomes. I think Jacob did a great job of talking about when you're in these floodplain systems, there's going to be particular species or life stages that are important. We care about our salmon. We care about making food on the floodplains. Maybe you wouldn't care about those as much if you were in a different geomorphic setting where that's not really as relevant. So we can start to prioritize our ecological outcomes, which is an important part of Tier 2 of CEFF. Also, the environmental flows methods. There may be certain methods that are much more or less relevant depending on what geomorphic setting you're in. So some of these entirely flow-based methods like Aloha may not be appropriate when you're in a really unique or highly variable geomorphic setting, where it might make more sense to use a higher resolution hydraulic modeling approach, for instance, or temperature information or something like that. So this is just showing the functional flows framework, right? The idea is there are these hypotheses about these components of the flow regime that are affecting your ecological outcomes, but we're just saying that those hypotheses may be modulated by what channel setting you're in. Also, we can use this information to constrain the flow criteria by channel type. So again, you release this flow, it's going to do really different things, whether these high winter floods are going to do very different things when you're in this wide, shallow, meandering system versus this deeply entrenched channel. So it may be, we're talking about these functional flow boxes, these components, which is the natural ranges of those functional flow metrics. It might be that a smaller subset of that full natural range for that stream type is actually going to be achieving the function that you're interested in. So taking the time to think about what are the functions, and should we make those boxes smaller than the full possible range to account for what it is we're trying to achieve. Also, this is going to be helpful for upscaling site-specific information. We can't go and survey all of this sediment, slope, all this information at every stream reach in the state yet. And so in the meantime, we're trying to use this information to generate synthetic terrains using this modeling tool that we're developing called River Builder. And you can see a cool example here. We're basically generating synthetic terrain and playing around with different flow scenarios in these different channel configurations and playing with slope and sediment composition and all of these features to think about how that's going to affect aquatic species habitat needs across the state. So how does this work? Well, it's pretty simple. It's kind of like with the hydrologic classification that we didn't have time to talk about. So similar idea. You go into the field and you survey a bunch of stuff.
You get things related to your channel cross-section, your slope, sediment composition, all this. We throw it all in these statistical analyses to pull out sets of sites that we expect to have similar channel characteristics. And then we're using state-of-the-art machine learning techniques to extend that information about those different channel types that we've identified in a region to the rest of the landscape at the NHD segment scale. I think eventually at the 200-meter scale. And that's using publicly available geospatial data related to, well, basically everything we could find for the state of California that could possibly affect your reach scale geomorphic setting. So in order to balance capturing the full range of regional geomorphic variability with detailed information within a reach that you would expect to influence your aquatic species and your ecological outcomes, we did a tiered approach to selecting sites. So first we looked across the state and we split up the landscape, these stream reaches, based on valley confinement, sediment supply, contributing area, and slope, all of which were extracted from geospatial databases, mostly topography. And then we binned the landscape and tried to survey across different combinations of all of those in the hopes of capturing a range of the reach scale channel settings we were seeing. And then we went into these settings and again calculated a whole bunch of stuff, mostly just using pretty low-tech equipment, just measuring tape and surveying level and a bunch of undergrads, and collected a bunch of data that essentially is what is in the PHAB database, and then some additional information to start to get at the sub-reach scale variability and look at how depth and width and channel width vary longitudinally and co-vary to better capture the hydraulic patterns and habitat that we expect to see. So then what does a suitable classification look like? We have all of these sites that we've gone in and surveyed. The next step is basically to go through and interpret the statistics, use them as a tool, but also go through mindfully with a bunch of geomorphologists and try to understand, well, what are we really distinguishing here? Unconfined from confined valley settings, high topographic or low topographic variability, high slope, sediment composition, and eventually you have to draw some line. This is an example of one type of clustering approach, but this was based on a whole bunch of different tools. You draw some line and you say, okay, these are similar, they're all in one channel type. These are different in order to have a minimum number of channel types, but still be really capturing these important features. So we've spent a lot of time on that. And as of now, with the combination of swamp data and all of our survey data, we have over 600 sites that have been surveyed across 6 regions in California, which you can see here. We started with the Sacramento and the South Fork Eel, which is that really black area in here. And now we'll have 8 regions in total, all of the areas that are lit up here. And so 2 of them are completed, and then 6 hopefully will be completed by 2020. But right now it's a work in progress. There's a lot of people out in the field probably as we speak. So it's been a big data collection campaign and getting all of the protocols very scientifically defensible and the ability to train different regions that are working with us. Right now we have groups from Humboldt State, Southern California Coastal Water Resources, Monterey State, UC Davis, all of these folks who are working with us to help go out and collect the data. So it's a lot of really smart scientists involved in this process. And just an example, so this is the classification of the Sacramento River Basin. You can't really see much of this, but there's, I think it's 10 channel types. So they're again distinguished across those attributes that I mentioned, boulder bedrock. So you end up seeing there's these really unconfined streams down in the valley, and then you get into more of these confined settings, and the sediment composition kind of varies. And this was all predicted at that really fine scale. This is an example for the South Fork Eel. Almost all of the channel types here are much more confined, coarser sediment. You have that really high relief coast range topography, high sediment load. And finally, I just want to talk about, so this has been a huge effort, and we've put a lot of work in, but there's really, even though 600 sites sounds like a lot, there's a lot more work to be done. There's still a lot of uncertainty in the prediction of your channel setting at locations that have not been surveyed. So we're really interested in getting support from other folks in California to help increase the coverage of these sites and reduce uncertainty in our classification. And it's really fun, you get to go do that. So a couple options that I want to throw out there. One is ground truthing the classification, so going out to some site, any site now will have a prediction of what channel type you're in. Going out to that site and just looking at we'll have a database showing, if you're in channel 1, it should look something like this. If you're in this other channel type, it should look more like this. And just saying, does this make sense? Do you feel like you agree with the predicted channel type? We're also developing some heuristic tools. So this basically walks you through and you say, what is the valley setting? Am I confined or unconfined? And then you walk through this tree and it says, okay, if I'm confined, well, what's my sediment composition? And eventually you would assign a site to a certain class. And we can go back and use that to ground truth our prediction. Similarly, we've developed an app that is available, or we can make available, called the California Geomorphic Classification Field Survey app. And this is all of the information that our crews are actually going out in the field and collecting. So you can bring an iPad or whatever and walk through each of the steps. We have very detailed protocols and really go in and collect data for an entire site. And this can either be broad site selection, where you just are somewhere collecting bugs and you say, we're going to go do the geomorphic survey as well, or targeted site selection if you're in a region and you think the current classification doesn't sufficiently capture some channel type and you want to make sure it's accounted for, or some other reason. So there's a lot of opportunities there to help improve the classification effort. And yeah, I'll stop there for now. Thank you.
Great, thanks. And then I'm going to invite all of our panelists back up, but just to follow up on what Belle was saying on that last part, we're really excited about this idea of the citizen science and something like maybe like an iNaturalist type of app where people can verify the classifications, and so really engage all the watershed groups around the state that can help us build on some of these tools over time. So with that, I think I have about 15 or 20 minutes left, or about. Yep. So what I'd like to do is invite all of our speakers back up, and then we have time for sort of an open discussion. What we try to do is provide kind of a broad overview of the policy drivers, what the environmental flows framework is, and then some of the specific tools that are being developed to support development of these ecological flow criteria around the state. And so now we have some time for some general question and answer. Yeah. Are those mics all on? 15? Okay. All right, so we'll open it up. I have some prompts, but I'm guessing there's lots of questions out there, so we'll start with the audience.
Thank you.
Yeah.
Thanks for all the talks. I had a few questions kind of related to how you're looking to manage this, where we're going with policy and management. And the first thing the only thing I can think of, I guess, in terms of managing flow is pulses from dams, better water management. So when you look at, let's say, a river system like the Carmel River, where you've had so much drawdown of the aquifer, and you're combining that with this seasonality, this lack of seasonality, how do you manage that, restoring the groundwater while also trying to get that, balance those flows again? And then on top of that, I'm just kind of curious if you've thought about, the other technological tools for managing, like mini hydro or things like that you can kind of get into the system. So.
Dan, you want to answer the policy?
Okay, I'll do the science. Dan's going to do the policy.
Okay, perfect.
Okay, so from a more scientific perspective, okay, I don't have to hold it down. Sorry, you told me to push the button. Just once. Okay, so the way that I would look at the functional flows approach is it can be bottom down, or bottom up, or top down. So if I'm in a dam, I might be adding and building up flows to get to my functional flows. If I'm in a diversion setting, which is what you're describing in the Carmel, then I'm limiting diversions. And I'm coming from a top down to say, yes, you can take here, but no, you can't take here during this time. And the connection with the groundwater is huge, of course, as we know. That's one of the aspects that several of us we've been talking about. How does this mesh with Sigma and the new relations there? But again, the idea is that the flow criteria sort of provide bounds, which you ideally do not want to go above, and ideally you do not want to go below. So the application of it then makes it very simple in a lot of different places, right? And it can be used in a lot of different ways. And a lot of the rivers might have 3 of the 4 that are naturally happening, and maybe you're really concerned about one. Or if I'm in a fully regulated system like below Shasta, then you're really trying to manage across the whole flow regime. So that's the science side.
Sorry, I just wanted to add something to the science side. I think the other piece of this is the two tiers. So tier 1 with the functional flow metrics based on unregulated flow is meant to apply everywhere and be broadly ecologically protective. But there's going to be places where you either don't want to meet it or you can't meet it or you want to refine it or whatever. And then that would bump you into a tier 2 process where you would come up with another methodology, which we're going to provide guidance on how to do that, to come up with a different set of functional flow metrics, or the different values around that. And the important part, though, about going into a tier 2 process is that you have to have management objectives. So there has to be a reason, not just like, I don't feel like meeting these, but like, what am I trying to achieve in this place? And select your methodology based on those objectives.
And then from a policy standpoint, you picked a tough one, groundwater and surface water impacts. You know, a lot of times when we start to look at that from policy, we're going to start looking at a more robust analysis of surface water, groundwater interaction through modeling and those type components to get at how the two are interplaying and where different impacts are occurring during different times of year to help mitigate some of those impacts. From a coordination effort, you could look at it a couple different ways depending on how you want to approach the situation. You could look at these are the minimum flow targets we're looking to achieve in stream. And if they're not being achieved because of groundwater extractions, then that would go kind of more over into the Sustainable Groundwater Management Act as targets that they're trying to hit as far as balancing the losing reaches. If it's more the other way, then really it's looking at how do we make sure that we're providing those high flows during the winter to restore the groundwater table if it's more of a short-term impact versus a long-term impact. So it depends exactly what the situation is. In some of our efforts that we're undertaking for the California Water Action Plan, we are looking at more of that more detailed modeling effort of the surface water and groundwater modeling to try to get at some of those impacts.
That was a wonderful presentation all the way around. I think the Belize, Sarah, Julie, the level of progress and the science that's driving that as far as understanding how things worked, how the landscape functioned, is absolutely the basis for moving forward, for making informed policy decisions. And I think it's wonderful to see what the last 5 years have brought. There's this place that we've touched on, which is, I think you did a good job, Bailey's, in talking about the geomorphic context being absolutely necessary in talking about flow. The impact of that flow is going to be very, very different depending on not just the channel classification and not just what it was once on the landscape, but what it is. And that gap between what we think it functioned as to how it functions now, this idea of tier 2 that you were just putting in, Julie, seems absolutely critical. Maybe a larger context for that is this word flow. So often I still hear flow and you could substitute volume of water. Increasingly, you could hear volume of water at a certain space at a certain time. That's helpful, but we all talked about pattern and how that pattern might actually be more important than the volume itself, and trying to broaden that out, trying to really get at that translation between the volume of water being put in the stream, but what the impacts are and how that is really at the very core of all three of the models that you guys are putting forward. So it's not so much a question, although I do have a couple, like how, Bailey's, does your model deal with the fact that with the built environment, so with the Central Valley of Sacramento that looks nothing like the unconfined geomorphic channels that it once was. Or there's more subtle ways. You can look about the Yuba, right? So the Yuba is still an alteration, but it's an alteration that happened at a landscape level over, well over a century ago, over decades, that fundamentally has changed the way the water flows, those patterns, what's possible. So the reason I'm bringing that stuff up is because that's where the challenge is. That's where the people are. That's where the water demands are. And if we don't make that stuff transparent now, I fear that we could end up at loggerheads again, where we have environmentalists saying we need this kind of flow here, and you're saying people on the other side that are using that water saying that's insane, and then not being able to bridge it. So it seems like we have the context to bridge that, but maybe that's, I know it was too much talk, and but maybe you guys could just pick a piece of that makes sense, because I know you're all thinking about that idea of what flow actually is.
So maybe I can translate that into a couple of questions for the panel and see if I capture that, Jacob. It seems like one of the questions is sort of how to set expectations given sort of the sort of systemic changes on the landscape and unpredictable future changes. So how do you set reasonable expectations? Seemed like one of the questions you're asking. And then the related question is then how do you balance that, balance those expectations with some of the other demands on these highly constrained landscapes? So maybe that's a couple of questions that were embedded in there.
I guess maybe I should start by just putting a few caveats on my recent presentation, which is that we're trying to classify the current setting of relatively, in huge air quotes, relatively unaltered channels. So we have not yet gotten into the super highly altered Central Valley systems, and we're trying to say at a regional scale, for instance, if you're looking, and this is another example of a method that may be more or less useful depending on what region or what setting you're in. So in the South Fork Eel watershed, there's definitely been channel alteration, but fundamentally we can try to understand, are you in a pool riffle system or a cascade or this wide kind of meandering system that has some floodplain pockets? Whereas we're not yet at the point of being able to understand what the current geomorphic setting is in some of those more lowland, heavily altered systems. Go ahead, Dan.
Yeah, and I would add, so that's kind of the next step in the process is right now we've identified kind of what the expected geomorphic setting would be under more natural conditions. The second step is to evaluate what if the current geomorphic setting is functioning that way, or if it's gone through alteration. In that case, can it be, if we add flow back into the equation, what was the driver of that alteration? Can it be restored back towards its natural function geomorphic setting? Or have we now pushed it so far that we have to manage that as a different channel type altogether? So we're looking at different options to try to get at some of that. We're looking at whether or not we can use some of the LiDAR. There's supposed to be a better survey of LiDAR coming out soon. A lot of the more impactful areas that we find where we have more significant geomorphic change from human causes is in the lower land areas, where hopefully we can get better information from either aerial photos or efforts through aerial photography, satellite imagery, or through LiDAR to start to develop what the current setting of that geomorphic channel is so that we can get at that change. The second component is whether or not, as I mentioned, touched on a little bit, whether or not flow is the answer, whether you just we can use flow to restore the functioning of that ecosystem, whether we also need to couple that with restoration activities for, like if it's something simple to pick low-hanging fruit, if it's a levee system, and we're trying to operate within that levee, that's going to be very difficult. So trying to look at restoration to open up portions of that levee to create some floodplain habitat and stuff like that in combination with flow.
But the channel types they're based on what we're seeing over hundreds of sites that we're surveying. So they are going to reflect some of the major current alterations that we've seen. And I think that's important to keep track of. And the idea, again, is to focus on what would the flows do in these channel settings. And then we can start to play around with what happens when you start to actually tweak the landscape or start to prioritize where you want to put those flows.
Yeah.
Oh, and I also, really fast, sorry, think that this is another plug for the citizen science effort, because if we go in and people are going out to sites and they're saying this looks nothing like what the predicted channel type is, we might start to see patterns in what is driving some of these alterations and where they occur on the landscape, and use that to inform our modeling tools to better predict what we're seeing currently.
Okay.
You're going to get everybody jumping in on this one, Jacob. I don't disagree with anything that Dan and Bell said. I think I would just go a step up and say that to me, the Central Valley is not the natural setting anymore. It hasn't been in a long time, and therefore this tool may just not be applicable to that one, and that's okay. The idea behind this is that we want a suite of tools that we can put together in our toolbox. This is exactly what Tier 2 is about, is to be able to come in and say, okay, I'm in this incredibly highly managed system. I'm in Northern California. I'm up there in the Northern Central Valley, and there's no way we're going to knock down every single levee and tell the farmers that they can't farm so we can restore that. We get that. That's totally understandable. Our management objectives then in Tier 2 might be to figure out, can we meet any of the functions that we know we want to happen based on our knowledge and state of the science. And that's okay. I think that's perfectly fine. A lot of the geomorphic classification that Bell's been doing has a lot of place in the areas that are partially modified. My personal opinion is it's not applicable to the Central Valley. That's okay. Instead, we should be looking at models that are there. We should be looking at the more detailed data we have, and we should be looking into potentially different sets of tools that might say, is there somewhere on this landscape that we could restore more than just one function? Or can we do multiple objectives? And we still have those goals and those functions and processes as the goal that we're shooting for, but the tools we use to get there and the methods and decisions we make to get to that might just be a different set. And so I just sort of want to throw that out there as sort of a slightly different perspective.
Yeah, I completely agree. And that hierarchical framework then allows you to sort of walk through and prioritize your resources effectively and say, okay, we have tools that we can get at these systems relatively well with. Let's start with that and then focus on, getting that high resolution terrain in systems where we really need it and we don't have that information or this isn't relevant.
Okay, so we're going to have to wrap up. So Julie, I'm going to give you 30 seconds to have the final word.
I get the last word.
Yeah.
So this whole set of tools is statewide, and 86% of streams are poorly gauged. Even fewer of those have flow recommendations on them. So this is meant to say, let's have a baseline so that we have a flow recommendation everywhere. And most places, we don't know what our management objectives would be. We haven't done that work. And so this would apply, Tier 1 would apply. In the Central Valley, we've, battled that out in a lot of places, and we're still working on flow. We're still working on the objectives, and I've done a lot of work on that. And I think that's where we have to go. I totally agree with Sarah that Tier 1 wouldn't apply there. But we should have the processes where we say, these are what our objectives are. This is what we're trying to achieve for these places. Let's look at the trade-offs in a Tier 2 context. And that footprint would just, go over the Central Valley, and you wouldn't do Tier 1 in most places there.
Okay, great. So as we wrap up this panel, clearly a lot of work's been done, but this is still a work in progress. So Dan in his opening talk gave you some web links that you can, and the LIRIS listserv and opportunities for continued engagement. So if you're interested in this topic, you can go to the various websites and sign up for lists and stay engaged in this process because it's still ongoing. So with that, I'd like to thank all of our panelists and all of you for some stimulating discussion. And do you have any announcements before we go to break? Or? Oh. I'll turn it back over to Greg and then give our panelists a round of applause.